Hi primary teachers, welcome to Best Practices Weekly. I'm really excited to share with you a mathematics framework for our math blocks that I learned about in the article that I read this week called Increasing Participation Through Differentiation. And that's a really big article, and we all know differentiation is a really important thing for us to do with our students. But it's really hard to find time in our math block to build the fluencies and skills and the gaps in knowledge that our students are missing. And this framework really lays out for us a math block that will make it easy for us to do that and still meet the needs of small groups and really encourage everyone to participate in mathematics every day, even those kids who are frustrated with math. So I can't wait to share this with you over a two-part special. So this is part one. We're going to delve into the first two components of the framework today and kind of the background on it. And then next week we'll publish part two, which will delve into the last two components of the framework and also the best practices that we can pull out of this for our primary classrooms. So I hope that you'll join us for both of those, and I can't wait to hear from you with some ideas that you've taken from these best practices back into your classrooms. So let's get started. Increasing participation through differentiation can be found in the October 2012 edition of Teaching Children Mathematics. The balanced mathematics framework that we're going to look so closely at today and next week is developed by the Madison Metropolitan School District. And it's actually a framework that provides opportunities for teachers to differentiate in a variety of ways for students. And it gives all students a chance to participate in equitable math instruction. They're actually a lot of times choosing the level of participation that they're going to have. So it's highly student-centered and high interest level for the students. Looking at the balanced mathematic framework, there are four parts. Inspecting equations is the first part, and that usually lasts between 5 and 10 minutes. Think of your bell ringer, your warm-up, your mini lesson. Number work is some heavy lifting with computation, usually done in about a 15 to 25 minute whole group lesson. Problem solving is done in small groups and can hit on problem solving within every strand of your mathematics. That's a 20 to 25 minute session per small group that you meet with. And fluency is an individual activity through something called math boxes that we're going to talk about on next week's video. And that is about a 25 minute time period per child. Sometimes some of the number work is folded into the fluency and math boxes as well. But those are the major components of the framework that we're going to be breaking down what each one of them looks like today and next week. Inspecting equations is whole group work that happens every day, and what it is doing is helping students understand the concept of equality, that behind an equal sign isn't just the answer, but that it means what is on one part of the equal sign is the same as what is on the other part of the equal sign, and then it also delves into what symbolic notation looks like. Now, through this article, they traced what inspecting equations look like in a first grade classroom. And so let's take a look at what kind of algebraic thinking these first graders were able to do. In this first grade classroom, the students came to the carpet with their algebraic thinking notebooks, and they were told to choose a just right set of numbers and to write as many true equations as they could about the numbers that they chose. The numbers range from numbers like 2, 3, 5 to a set of numbers that was 3, 5, and 15. So that allowed for immediate differentiation because some of the students chose to multiply and divide, and some of the students chose to come up with addition and subtraction problems. While students were brainstorming and coming up with the equations to put in their notebooks, the teacher wandered around the carpet to make sure that the students were choosing just right numbers. And there were times when she said, I think that you should try the blue set of numbers today, and then challenge someone else to try the green set of numbers, just to make sure that students were really making the just right choices that would allow them to participate and be as successful as possible during the inspecting equations part of the lesson. Just reflecting again on what the inspecting equations part of the math block is for, it is really building algebraic thinking in our young students. So it's getting them to think about equations as more than just what does the equal sign is there for the answer, but that what is on one side of the equation has to be balanced with what is on the other side. So it's really getting them to think algebraically. The fact that they have different numbers to choose from is an automatic way for differentiation. It allows the teacher to move around the classroom to see who is participating and how they're participating. And that at the end of the inspecting equation times, which really only lasts 5 to 10 minutes, students are turning with a partner and sharing the equations that they had. So everyone is encouraged to participate. It's okay to make a mistake at that point because you're talking about it with your partner. So there's not a lot of risk involved, and everyone can participate in the discussion at that point. The number work component of the framework, which is a bigger part of the lesson, 20 to 25 minutes, is something that the framework encourages to be done whole group. So these are your number sense and computation work based on your grade level standards. These are separate and apart from story problems. So this is the computation work where you're working through procedure so that students can have success when they're transferring that knowledge into the application piece of math, which is the actual story problems, where you're going to be able to provide high levels of support because the story problems are done in small groups. But whole group, you're developing number sense through computation work. There are times when number work can also be included in the math boxes, which is kind of an individualized math time, which we're going to hit on the math boxes in next week's episode, where we cover the problem solving and the fluency development, and the math boxes come into play during the fluency development time of this math block. So number work, think whole group work, you're focusing in on number sense and your grade level math standards related to straight computation. I hope you're catching the excitement about this framework that I have, and I hope that you're thinking about ways you can implement these ideas into your math block, because I really feel like this structure that the framework provides for us can really change the way that we deliver, differentiate, and increase participation during our math block. So stay tuned next week, where we'll delve into what the problem solving portion of the framework looks like with small groups, and the fluency and maintenance portion of the framework, which includes the math boxes we've talked so much about today. I can't wait to share that with you, and thanks for joining us today.